Everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter Electrostatics. Any doubts if you have, please write that in the comments. We shall obviously clarify them. And any other chapter of physics, if you have more difficulty, then please mention the name of that chapter also in the comments. Then we shall give more priority on it and solve more and more questions on that chapter, which shall be obviously helpful for your exam. And please install our Sapience education application, whose link has been provided in the description. So here it is told two isolated metallic solid spheres of radii r and 2r. Two isolated metallic solid spheres radii r and 2r charged such that both have same charge density sigma. The spheres are then connected by a thin conducting wire. If the new charge density of the bigger sphere is lambda dash, the new charge density of the bigger sphere is sigma dash, then sigma dash by sigma is equal to how much? When they are connected by a conducting wire, then the potential will become same. Potential will be same. Now sigma is equal to q by, if the charge on the smaller sphere is q, so then I can say q by 4 pi r square. Sigma will be equal to here q dash, q2 I can say. Q2 is the charge on the second sphere, so q2 by into 2r whole square. Therefore, sigma will be q2 by the 4, 4, 4, 16, 16 pi r square. So therefore, we can say that q2 by 16 pi r square, that is equal to q by 4 pi r square. Pi r square will cancel, so q will be equal to 4q. So the charge on the second sphere, that is equal to 4q. So now sigma dash, now its new charge density is sigma dash. So now therefore sigma dash, I can say it is aq dash divided by 2 dash divided by 2r. Sorry, sigma dash equal to q2 dash by 4 pi into 2r whole square is equal to q2 dash by 16 pi r square is sigma dash, and charge q will flow from the smaller sphere to the larger sphere so that their potential is the same. aq2 dash by r, that should be equal to kq1 dash q1 dash by r. Kk will cancel, rr will cancel, so q2 dash will be equal to 2 times q1 dash. If charge q has flown, I can say that dash that will be equal to 2 plus q. Since initially the larger sphere of radius 2r had charge 4q and the smaller sphere had charge q, its radius was r. And if q charge goes from smaller sphere to the larger sphere, then it means that q2 dash will be equal to 4q plus q, and q1 dash will be equal to q minus q. Now here it is that q2 dash that should be equal to Q1 dash. Dash should be equal to 2 1 dash. So therefore Q plus Q that should be equal to Q into minus Q. Therefore I can say 4Q plus Q that is equal to Q that is equal to 2Q 2Q. I can say that 2Q that is equal to plus 4Q that is minus 2Q equal to minus 2Q by 3. It means that this small charge Q 2Q by 3 has flown from larger sphere to the smaller sphere, it's 2Q by 3. 2 by 3 charges flown. Therefore, therefore 2 dash that will be equal to 4Q plus Q, that is 4Q minus 2Q by 3, that is equal to 4 is 12, so 10Q by 3. So now sigma 2 dash in sigma dash is equal to Q2 dash by 16 pi r square. 2 dash by 16 pi r square. Equal to 10Q by 3 by 16 pi r square. And sigma equals to Q by 4 pi r square. So now sigma dash by sigma, that will be actually 10Q by 316 to the 48 pi r square divided by sigma Q by 4 pi r square. This will be 10Q by 48 pi r square into 4 pi r square divided by Q. So Q will cancel. Pi r square cancel. 4 under 4, 2 and 4 is 48. 2 6 are 12, 2 5 are 10. So this is equal to 5 by 6. Sigma dash by sigma that is equal to 5 by 6. So option B is the correct answer. Is told point charge 2 into which is Q equal to 2 into 10 power minus 2 coulomb that is moved from point P to the point S in a uniform electric field that is equal to this is the positive x-axis. Suppose if it is 30 Newton per coulomb, which is directed along positive x-axis, means it is along I cap. If coordinates of point P are 1, 2, 0 and S is 0, 0, 0, 0, 0, 0. So it is S is actually the origin and unit is in meter only. So to do the work done by the electric field will be work done by the electric field that is equal to force into displacement. Force into displacement that is delta R vector. So force will be equal to Q into E dot delta R, which is delta R vector that is equal to E to S. So E as vector is the displacement that is equal to it's minus I cap minus 2j cap meter. QE into QE dot minus I cap minus 2j cap joule. So the electric field Q is 2 into 10 power minus 2 coulomb into 30 Newton per coulomb into I cap dot product with minus I cap minus 2j cap. So this will be I cap dot minus I cap, that is minus 1, that is minus minus 2 into 10 power minus 2 into 30. This is 60 by 100. So that is minus 0.6 joule. It is minus 600 joule. Minus 600 joule. So option D is the correct answer. And here is told a cuboid. There is a cuboid. There is a cuboid of dimension 12, length, breadth, that is 12, and height is L. Charge Q is placed at the center of the surface S dash. The charge Q is placed at the center of the surface S dash. It is placed at the so I can place it at the top surface or at the bottom surface, the center surface S dash. Its area is 4L square. Area of the top surface is also 4L square, and area of the bottom surface is also 4L square. Now the flux through the opposite surface to S is given by flux through the opposite surface to S. Flux through the opposite surface to S. That is asked. So if we complete this and form a cube, if we form a cube which is of side length L, which is of side length 2L, height is also 2L, then this charge will be at the center, and then cos integral E dot ds, that is the flux phi net is equal to q by epsilon, q enclosed q by epsilon naught. Now to each surface, so each face, there are 6 faces. So through each face equal flux will pass through. Therefore, the flux through the face opposite to this charge, that flux by E dash, that will be equal to q by 6 epsilon naught. Option D is the correct answer. Then it is told point charge of 10 micro point charge of 10 microcoulomb is placed at the origin. It's at 0,0,0 at the point of 10 microcoulomb charge is placed. I can say at what location on the x-axis should a point charge Q1 of 40 coulomb be placed, so let's say it is placed at x comma 0,0, so that it is placed at a comma 0,0, such that the net electric field is 0 at x equal to 2 centimeter on the x-axis. The net electric field is 0 at x equal to 2. See that x equal to 2 centimeter on the x-axis. So here the net electric field is equal to 0. Electric field at x equal to 2 centimeter is 0. So here the net electric field that will be equal to here E1, let's say this is E2, this is E1, but these two should get cancelled. So E1 that will be equal to KQ1 by R square. So that is, let's say if I tell this is actually length, this length will be A minus X. Minus X whole square, and E2 that is equal to AQ2 by X square. Where K is equal to 1 by 4 pi epsilon. Okay. Now therefore E1 should be equal to E2. Their magnitude should be same and they are opposite in direction. Therefore they will cancel, and the net electric field will come 0 at this point at x equal to 2. It means this point is 2 centimeter, 0, 0. So E1 should be equal to E2. So I can say KQ1 by A minus X whole square. That should be equal to KQ2 by X square. KK will cancel out. Q1 that is 41 micro divided by A minus 2 whole square equals to, so A will come in centimeter only. A will come in centimeter only. Since X we have taken in centimeter, X is given in centimeter. So 40 by A minus 2 whole square, that is Q2. Q2 is 10 microcoulomb by X square. X is 2 square. Therefore, we can say that this will be for the 16. 16 will be equal to A minus 2 whole square. For the 16 equal to for the 16 equal to A minus 2 whole square. So A minus 2 will be equal to plus or minus 4. Therefore, A can be 2 plus 4, 6 or minus 2, but A cannot be negative. So A should be 6. So therefore, 6 at x equal to 6 and centimeter, the 40 coulomb charge should be placed. So option A is the correct answer. Here it is told the electric potential at the center of two concentric half rings of radii. The electric potential at the center of two concentric half rings of radii R1 and R2 having same linear charge density lambda is Okay. The electric potential at the center of having same net charging in the pocket. So here the net electric potential, that will be V1 plus V2, means the potential due to the smaller ring plus the potential due to the larger ring. So the length of the smaller ring L1, I can say that is equal to pi R1, and the length of the larger ring, that is equal to pi R2. So now the net charge Q2 in the larger ring, that is equal to obviously lambda L2, that is lambda pi R2, and the net charge Q1 in the smaller ring, that is lambda L1, that is equal to lambda pi R1. So V1, that is equal to P by R, so it is KQ1 by R1 plus KQ2 by R2. So this will be A means 1 by 4 pi epsilon naught into this is Q1 is lambda by R1 plus this is Q2, that is lambda by R2 by R2. R2 will cancel, R1 will cancel, so pi. So this is 2 pi lambda by 4 pi epsilon naught. So this is pi will cancel, 2 2s are 4. So it is lambda by 2 epsilon naught. So lambda by 2 epsilon naught. So option A is the correct answer. And here it is told if two charges Q1 and Q2 are separated with distance d. Q1 and Q2 are separated with distance d and placed in a medium of dielectric constant K. What will be the equivalent distance between charges in air for the same electrostatic force? So here the force in the medium, the force that will be equal to Q1 Q2 by 4 pi epsilon naught into epsilon r, means the dielectric constant K into d square. And in air, let's say the separation should be d dash, and for air the dielectric constant is 1. So Q1 and Q2 are placed at a separation d dash, so d dash should be how much, that is asked. So the new force also should be the same only, the dash, that is Q1 Q2 by 4 pi epsilon naught into d dash square. So this should be equal to F. So therefore Q1 Q2 by 4 pi epsilon naught into d dash square, that should be equal to Q1 Q2 by 4 pi epsilon naught K into d square. Q1 Q2 will cancel, 4 pi epsilon will cancel, so 1 by d dash square, that is equal to 1 by kd square. So therefore we can say that d dash square, that is equal to kd square. Therefore d dash will be equal to d into root k into d root k. D root k. So option A is the correct answer. It is told 3 point charges Q1, Q minus 2Q and 2Q are placed on x-axis at a distance x equal to 0, x equal to 3 r by 4, and x equal to r respectively from the origin. So this point is the origin, obviously. If Q equal to 2 into 10 power minus 6 coulomb and R is 2 centimeter, the magnitude of net force experienced by the charge minus 2 coulombs. So minus 2Q will experience attractive force towards 2Q and attractive force towards Q. So let this be F1, this is F2, or this is F1, this is F2. So therefore the net force be equal to obviously F2 minus F1. Since here we have larger, the charge is magnitude of the charge is higher, and it is more closer also to the with respect to the charge q. So F2 will be obviously higher than F1. Means the magnitude of the force F2 will be more than magnitude of the force F1. So therefore F2 minus F1 is the net force on charge minus 2q. So that only we have to find out. Therefore the net force in the charge q minus 2q, that is F2, that is 2q into 2q. So 4q square q1 q2 by 4 pi epsilon naught into r square. So this length will be actually r by 4. This is r by 4 whole square. So q1 q2 by 4 pi epsilon naught r square, and minus this will be 2q into q, that is 2q square 4 pi epsilon naught into 3r by 4 whole square. These two will cancel, so 4 to the 16, so it will be 16 q square by pi epsilon naught r square, minus this is 4 to the 16, 16 to the 32, 32 q square by 3 to the 9, 4 9 to 36, 36 pi epsilon naught r square. This will be 4 8 to 32, 4 9 to 36. So therefore the LCM is 9 pi epsilon naught r square into this will be 16 9s are 9 6 are 54, 144 q square minus 8q square. So this will be 136 q square by 9 pi epsilon naught r square. Now 1 by 4 pi epsilon naught, that is equal to 9 into 10 power 9. So therefore 1 by pi epsilon naught value, that will be 4 9 36, 36 into 10 power 9. Therefore the net force that will be equal to 136 into q square. Q is 2 into 10 power minus 6 whole square divided by 9. 9 r square. R is 2 centimeters, so r is 2 into 10 power minus 2 meter. 2 into 10 power minus 2 meter. So 2 into 10 power minus 2 whole square, and 1 by pi epsilon naught, that is 36 into 10 power 9. So this force to find out magnitude of this force. So therefore the net force, the charge minus q, that is 136 by 9 into this will be 36 into this will be 2 into 10 power minus 6 whole square by 2 into 10 power minus 2 whole square to 10 power 9 Newton. This will be 2 will cancel, 4 9s are 36. So 136 36 into 4 into this will be 10 power minus 4 whole square 10 power 9 Newton. So this will be 136 into 4 into the 8 minus 8, so 9 minus 8 is 10. Okay. So 136 into 40, 36 into 40 Newtons, so it will be 4 6 24. So 5440. 5440 Newton. So it is the answer. And here it is told a thin infinite sheet charge. Thin infinite sheet charge and an infinite line charge of respective charge densities plus sigma and plus lambda are placed parallel at 5 meter distance from each other. 5 meter distance from each other. Points P and Q are at 3 by pi meter and 4 by pi meter perpendicular distances from line charge towards the sheet charge respectively. It means here we have a plane sheet of charge. Here we have a line charge. It is plus sigma, this is plus lambda, and this length is 5 meter. And here we have point P, here we have point Q. So this length is 3 by pi meter and this length is 4 by pi meter. Perpendicular distances from the line charge towards the sheet charge. EP and EQ are the magnitudes of resultant electric field intensities at points P and Q. So EP is the electric field at the point P and EQ is the electric field at the resultant electric field at the point Q respectively. Then EP by EQ. EP by EQ that is equal to 4 by A. 4 by A for 2 sigma, 2 mod sigma is equal to mod lambda. Then the value of A is. So value of A we have to find out. Now electric field. Here we will have repulsion, the electric field at the point P that will be equal to, here there is repulsion, here also there is repulsion. This is here we will have sigma by 2 epsilon naught and here we will have 2k lambda by r. So now 2k lambda by r, which is lambda by 2 pi epsilon naught r. So therefore at the point P, lambda by 2 pi epsilon naught r value that will be equal to lambda by 2 pi epsilon naught into 3 by pi. Pi pi will cancel, which is lambda by 6 epsilon naught. Here it is told sigma equal 2 sigma equal to lambda. So this will be 2 sigma by 6 epsilon naught. So this will be equal to sigma by 3 epsilon naught. But here we have sigma by 3 epsilon naught. So on towards the left and towards the right we have sigma by 2 epsilon naught. So 1 by 2 is obviously more than 1 by 3. So therefore this way it is higher. So the net electric field at point P, that is sigma by 2 epsilon naught minus sigma by 3 epsilon naught. So which is sigma by 6 epsilon naught. So minus 2, which is 6 sigma by 6 epsilon naught. And similarly, electric field at the point Q, that will be equal to here we have sigma by 2 epsilon naught towards the right, and towards the left we will have 2k lambda by r, which is at point q, this lambda by 2 pi epsilon naught r, that will be lambda by 2 pi epsilon naught into r. R is 4 by pi. Pi will cancel, so this is lambda by 8 epsilon naught, and lambda is 2 sigma, so 2 sigma by 8 epsilon naught, which is sigma by 4 epsilon naught. The sigma by 4 epsilon naught is towards the left and sigma by 2 epsilon towards the right. So the net electric field will be towards the right only. So this is sigma by 2 epsilon naught minus sigma by 4 epsilon naught, which is sigma by 4 epsilon naught. So now, therefore, it is told EP by EQ. EP by EQ is equal to 4 by A. So then A will be how much? So now, here you can see here EP by EQ, the electric field at point P by electric field at point Q. Electric field at point P is sigma by 6 epsilon naught, and EQ, that is sigma by 4 epsilon naught. So now, sorry, sigma by 6 epsilon 4 epsilon naught by sigma. Sigma and sigma will cancel. Epsilon naught will cancel, which is 4 by 6. Therefore, EP by EQ is 4 by 6. So therefore, A will be equal to 6. Therefore, the value of A is 6. So 6 is the answer. Then here it is told 64 identical drops, each charged up to potential 10 volt, are combined to form a bigger drop. 64 identical drops. 64 identical drops are charged up to potential 10 millivolts. So now we know that KQ by R, KQ by R will be equal to 10 millivolt, just 10 into 10 power minus 3 volt. Now Q into, so let's call this as V naught. So therefore Q by 4 pi epsilon naught R, that is equal to V naught. So each drop is having charge 4 pi R epsilon naught V naught. Now they are combined to form a bigger drop. So all are now combined to form a bigger drop. The potential of the bigger drop will be, so here charge, the net charge, let's say that is Q1. So Q1 will be equal to 64 times Q. Since we should apply the law of conservation of charge, so the net charge initially should be equal to net charge finally. Therefore, the potential of the bigger drop, that will be equal to K into Q dash by R dash. Sorry, K into Q1 by R1. Now R1, how to find? The net volume also will be conserved. We can say that 4 by 3 pi R1 cube, which is the volume of the large drop, will be equal to 64 times the volume of each drop, 4 by 3 pi R cube. 4 by 3 pi 4 by 3 pi cancel. So R1, that will be equal to 4R. Since cube root of 64 is 4. R1 is 4R. So that will be equal to K into, means Q1 by 4 pi epsilon naught into R1, that is 4R. And Q1, that is equal to 64 times Q. So therefore, the V1, that will be equal to Q1, which is 64 times Q by 4 16 pi epsilon naught R. So 16 4 64, so 4 Q by epsilon naught R. And now 4 by pi epsilon naught R is equal to 4 by pi epsilon naught R. That is 4 pi R epsilon naught V naught. So here pi R will cancel, epsilon naught will cancel. So it is 16 V naught. So V1 equal to 16 V naught. So therefore the potential of the bigger drop, that will be equal to 16 times V naught. V naught is 10 millivolt. So 10 millivolt, so that will be 160 millivolt. So 160 is the answer. And here it is told as shown in the figure, a configuration of two equal point charges Q naught equal to plus 2 micro its charge is plus 2 micro coulomb is placed on an inclined plane. Plus 2 micro. Mass of each point charge is mass is 20 gram. It means it is 0.02 kg. And assume that there is no friction in between the charge and the plane. For the system of 2 point charges, then mass of each point charge is 20 gram. Assume that there is no friction in between charge and plane. Assume that there is no friction in between charge and plane. Then for the system of 2 point charges to be in equilibrium at rest, the height is equal to height h equal to x into 10 power minus 3 meter, then x will be how much? So the two charges are at rest only. Their masses are there. So if we draw the free body diagram of this charge Q naught, so here the mg will act downwards, and there will be normal reaction obviously, and here will be the force, the electrostatic force, static force of attraction, where F will be equal to Q naught, and this will be, so if I take this as L, so L sine 30, that is equal to H, that is equal to H, so L is equal to 2H, since sine 30 is half, L is equal to 2H, so this length is 2H, so it will be Q naught square by 4 pi epsilon naught R square, which is 4H square. Q naught square by 16 pi epsilon naught H square. So this is the electrostatic force, and here here also there is a repulsive force actually. It's not attractive force. This will be repulsive force. This will be Fe. This will also Fe will act. Here mg is also there. Here reaction is there. Here we can say this will be 30 degree. This is mg cos 30, so mg root 3 by 2, and this will be mg sin 30, so mg by 2. Therefore, mg by 2, that should be equal to Fe, and N normal reaction, that should be equal to mg root 3 by 2. No friction acting in between the charge and the plane. It is no friction, so it is smooth. So now Fe H we have to find out. So mg by 2 that is equal to Fe that is q naught square by 60 pi epsilon naught h square. Now m so 2 8 is 16, so I can say that it's 4 pi epsilon naught. So 2 mg that is equal to q naught square by 4 pi epsilon naught h square. And 1 by 4 pi epsilon naught is 9 into 10 power 9. So I can say 2 mg, m mass is 20 gram. So 2 into 10 power minus 2 kg into g is 10, that is equal to q naught square. Naught is 2 microcoulomb, so 2 into 10 power minus 6 whole square divided by h square. H is x into 10 power minus 3 whole square into 1 by 4 pi epsilon naught, which is 9 into 10 power 9. So this will be 4 into 10 power minus 1 is 0.4. So then so square is 4 into 10 power minus 6 power 2, so 6 is 12 minus 12 pi x square into 10 power minus 6, 9 into 10 power 9. By x we have to find out. Therefore we can say 4 will cancel 4 0.1 and the 4. This is 10 power minus 1. So x square that is equal to 10 power minus 12 plus 6 plus 9 by minus 1, so 10 plus 1 into 9. So this will be x square that will be equal to 9 into 10 power 16, so 4. So x will be equal to 3 into 10 power 2. So x is equal to 300. So the value of x is 300. And here it is told an electron revolves around an infinite cylindrical wire. An electron revolves around the infinite cylindrical wire having uniform linear charge densities, lambda equal to 2 into 10 power minus 8 coulomb per meter. Circular path under the influence of attractive electrostatic field as shown in the figure. The velocity of the electron with which it is revolving is dash into 10 power 6 meter per second. And given mass of electron is 9 to 10 power minus 31 kg. So now as we can see that the centripetal force that is equal to m omega square r, or I can say mv square by r, mv square by r, where r is the radius of the circular path. So that will be same as the electrostatic force of attraction. So therefore mv square by r that will be equal to the electric field, as you know here this way it will be 2k lambda by r, which is equal to k lambda by r, that is lambda by 2 pi epsilon naught r. So therefore the force, electrostatic force, that will be equal to q e into e, that is e into this, so lambda e by 2 pi epsilon naught into r, so which is equal to lambda e by 2 pi epsilon naught into r. Velocity has been asked. So v square that is equal to lambda r e by pi m epsilon naught r. Therefore the square of the velocity of the electron, lambda, that is 2 into 10 power minus 8 into r. Okay, r will also cancel. So it's lambda e by 2 pi m epsilon naught. So E is the charge of the electron. It's 1.6 into 10 power minus 19 coulomb divided by 2 pi. 2 pi, that is pi is 3.1416 into m. Mass, that is mass of electron 9 to 10 power minus 31 kg, and by m epsilon naught. Epsilon naught is epsilon naught. Actually, we can say that 1 by 4 pi epsilon naught value, that is 4 in 9 into 10 power 9. So it means 1 by 2 pi epsilon naught. It means 1 by 4 pi epsilon into 2. So that will be 18 into 10 power 9. So this 2 pi epsilon naught, we can write it as, so it will be lambda e by m into 18 into 10 power 9. The second bit. So these two we can cancel out. Lambda e by m. M is 9 into 10 power minus 31, which is into 18 into 10 power 9. So this much meter square per second square. So we have to find the velocity. So it is the square of the velocity. So V is 18 to the 36 into 1.6 by 9. 36 into 1.6 by 9. Into this is 10 power 31 plus 9 minus 8 minus 19. But this I can write 16 into 10 power minus 1 into 10 power minus 1. So V square 36 into 16 by 9 into this will be 10 power. This is 40. So 40 minus, we have to do 28. So it is 2. So this is 12. 10 power 12. So therefore V will be equal to 3 3 is a 9. Okay. I'm sorry. I have to take square root of this entire thing. This is 6 6 is 36. 4 4 is 16. 3 3 is 9 into 10 power 6. So 3 2 is 6. So therefore V is 8 into 10 power 6 meter per second. 8 into 10 power 6 meter per second. So this will be 8 into 10 power 6 meter per second. I can say this will be so the velocity of the electron which is revolving is 8 into 10 power 6 meter per second. So 8 is the answer. Here it is told that three concentric spherical metallic shells, X, Y, and Z of radius A, B, and C. Basically, where A is less than B is less than C, obviously, have surface charge densities sigma, minus sigma, and sigma respectively. The shells X and Z are at same potential. X and Z are at same potential. So V at X, that is equal to V at Z. Then if the radii of X and Y are 2 centimeter and 3 centimeter respectively, the radius of shell Z is, so radii, that is told if A equal to 2 centimeter, B is equal to 3 centimeter, then C will be how much? That will be. Now the electric potential, at the shell X, the potential at the shell X will be equal to, this is KQ by R. which is at the shell X. So that is KQX by A plus KQY by B plus KQZ by C, where QX, QY, and QZ are the net charges of the shells shells X, Y, and Z respectively. So QX, therefore, that I can say it is sigma into 4 pi A square. QY, that is equal to sigma into, that is actually negative charge, so it is minus sigma into 4 pi B square. Sigma Z, that is equal to sigma into 4 pi C square. Oh, sorry, QZ, that is equal to sigma into 4 pi Z square. So therefore, this will be A by, so K is 1 by 4 pi epsilon naught into QX by A. So QX by A, that is equal to 4 pi sigma A. Then this will be minus 4 pi sigma B, and plus this will be equal to 4 pi sigma C. Plus 4 pi sigma C. So this is 4 pi sigma, I can take it as common, by 4 pi epsilon naught into A minus A plus C minus B. So 4 pi will cancel. So this is sigma by epsilon naught into A plus C minus B plus C minus B. And the potential at the cell Z, that is given as, that will be equal to KQX by C plus KQ, since the Z is outside the shell X and Y, so it will be KQY by C plus KQZ by C. This will be equal to 1 by 4 pi epsilon naught C into, this will be 4 pi sigma into A square minus 4 pi sigma into B square, then plus 4 pi sigma into C square. So 4 pi will come outside. 4 pi sigma will come outside. So it will be, so therefore the V at Z, that will be equal to 4 pi sigma, 4 pi sigma by 4 pi epsilon naught C, 4 pi epsilon naught C plus A square minus B square plus square. By 4 pi will cancel out. It's be sigma by epsilon naught. Sigma by epsilon naught into A square by C minus B square by C plus C. So here it is told that the radius of the shell Z, that is asked. A is 2 centimeter, B is 3 centimeter. So now therefore Vx, that is equal to Vz. So therefore I can say Vx, that is sigma by epsilon naught into A plus C minus B. So that is equal to sigma by epsilon naught into A square by C minus B square by C plus C. Sigma by epsilon naught, that will cancel. So I can say now A is 2, B is 3. A is 2, B is 3. So I can say A plus C minus B, that is equal to A square minus B square plus C square by C. I can say AC plus C square minus BC, that is equal to A square minus B square plus C square. Now C square will cancel out. So I can say C into A minus B, that is equal to A square minus B square. So C will be equal to A plus B into A minus B, since A square minus B square is A plus B into A minus B by A minus B. So A minus B will cancel out. So C equal to A plus B. So A is 2, B is 3, so C is 5 centimeter. 5 centimeter is the answer. Here it is told an electric dipole of dipole moment P, that is Q into 2A, that is equal to 6 into 10 power minus 6 coulomb meter, placed in an uniform electric field. So it is placed in an uniform electric field. It is placed in an uniform electric field. E is equal to 1.5 into 10 power 3 Newton per coulomb, in such a way that dipole moment is along the electric field. The dipole moment is also along the electric field. E is also like this. So then the work done in splitting this dipole by 180 degree in this field. So therefore work done, that is equal to minus of negative of the change in potential energy. So now potential energy, we know that is equal to minus E dot E, which is equal to minus PE cos theta. So therefore this will be equal to minus of U final minus U initial. So the final angle in between the electric field and the electric dipole, the final angle, that is 180 degree between the electric field and the dipole moment. But the initial angle theta is 0 degree. So I can say this will be U initial minus U final. So this will be equal to minus PE cos 0 degree minus of minus PE cos 180 degree. So this will be equal to minus PE cos 0 is 1 and cos 180 is minus 1, cos 180 degree, that is minus 1. So this will be equal to PE. So it will be equal to minus 2 PE. So that is equal to, therefore the magnitude of the work done that we have to find out. So that is 2 PE. So this is 2 into 6 into 10 power minus 6 into 1.5 into 10 power 3 joule. So this will be 2 into the 30, so 3 6 18. 18 into 10 power 3 into 10 power minus 6 into 10 power minus 3 joule. So this will be 18 millijoule. So 18 millijoule is the work done. So 18 is the answer.